Good afternoon. As you all know, I still remain my name Kazim. So I'm here to take this topic, dimensional analysis. So we want to find the dimension of this physical quantity, acceleration and work done. And what is dimensional analysis is how fundamental quantity or unit is related to what? To the physical quantity. So now, how do we solve this one? We have different dimensional analysis. We have the what? The length, which is denoted by L, and we have mass, which is denoted by M in capital, which is uppercase. We also have time, which is denoted by the uppercase T. We have many, even we have ampere like that. But these are the three basic dimensional analysis. You know, I said how it is related to fundamental unit. You know, fundamental unit is meter, seconds, like that. But for this, I want to solve this acceleration. We say acceleration, which is A, is equal to velocity over time. Acceleration is velocity over time. But in normal time, in normal real life, we have meter per second square. This is the unit of what? Unit of acceleration. Unit of acceleration, but not dimension. If your exam demand the dimension, not dimension. If the exam demand the unit of acceleration is this. But let's now go through the what? Dimension. Now, how do we do it? If you look at these three parameters that I wrote down here, we can see T here, which is denoted by capital T. We cannot see V. We have to break it down. We now say A equal to V multiplied by 1 over T. What is our V? Our V is displacement over time, which is called acceleration, velocity. So we can then say distance over time times 1 over T, which is equal to D all over T squared. Now, if you look at this one, this is distance, which is length. Distance is denoted by length because distance is measured in meter, which is length. So we can say that D is N, then T is T squared because the time is represented by T. So T squared. So if you now write this, it will be L times 1 over T squared, which is what? L T squared, which is equal to LT minus T. So this is the what? This is the dimension of acceleration. So this is our dimension of acceleration. So now to solve the work done, and you know what is said to be done when the point of what? When the point of force is moved, what is said to be done when the application of force is moved, meaning that what is equal to force times distance. Now we can see distance is L, but our force is not here, none of this. So we break down the force into F is equal to MA. We substitute into this, let's call this equation start. We now say work done equal to M times D. But if you see this one, we can see mass here. We can see distance here, but there is no A, which is A is our acceleration. Now, we now break A into what? Into velocity over time. Now, put your A, let's call this one equation star. Put your A into this. We have work done equal to M times V over T times D. Now, if you look at this one critically, there is mass, there is time, there is this, but we have any problem in V. V is not this. You break it down. So now say M times V times 1 over T. This is 1 over T times D. 1 over T times V. Now, what is our V now? You still break V into WD, which is work done, equal to mass times our V is equal to distance over time times 1 over T times D. So as you can see everything. Mass is there, which is capital D is N, T is there, then what? D is also there. Now, if you look at this one, we now multiply L times D times D. We have what? We have N D squared over then T times T squared. Then substitute this. Mass is capital N, then D is L squared, then over, then T is T squared. which is equal to m L squared then T minus 2. So therefore, the dimension of work done equal to m L squared T minus 2. If you look at the unit of work done, the work done is measured in joule. That is the unit. But dimension, if the question demands for dimension, this is the dimension of work done. Now, let me give you the class work. So how do you do this one? For instance, we are asked to find the dimension of pressure. The dimension of pressure. What is the dimension of pressure? So this is take home. But I will just try to give you hints. What is pressure? Pressure is the force acting normally per unit area. Pressure is the force acting normally per unit area, which means you start from this to get the pressure. So for this particular question, your answer is very paramount to me. So drop your answer in the comment section. For more inquiry or you need home lesson or online lesson, go to this page.